Two narrow slits are separated by, so this is our D, our little d, right? Are illuminated by monochromatic light. The fringes on the screen are 2.1 meters away, are 9.72 millimeters apart. What is the wavelength of light? Okay. Okay, so let's do A two different ways. Okay, let's do the approximate way, which is, by the way, good enough, but let's go for it. Okay, so S is in this equation, right? This is our S. This is our big D. That's our little d. The only thing we don't know is the wavelength, right? Okay, so 9.72, it's millimeters, so it's times 10 to the minus third, is equal to the wavelength that we don't know times the distance to the screen, which is 2.1, all divided by this guy, 0.0895, and that's millimeters, right? So it's times 10 to the minus 3. Okay. Now we're set. Okay, so I'm going to take this, multiply by this, divide by that. Okay. So 9 point. Stuff's in the way of my calculator. Okay. 9.72 times 10 to the minus third times 0.0895 times 10 to the minus 3 divided by 2.1, and I'm getting that the wavelength is 4.14 times 10 to the minus 7th meters, which would be 41.4 times 10 to the minus 8th, or 414 times 10 to the minus 9th meters, or 414 nanometers, as everybody says when they're talking about light. Okay. What angle separates? Okay, so let's imagine that you just don't like that, right? That we rather use this thing here, right? So the first thing I'm going to do is I'm going to figure out what that angle is. So theta is going to be tan minus 1 of this distance, 9.72 times 10 to the minus third, divided by 2.1 meters, right? Because I'm just doing distance to the screen, and here's some feature there. This is the adjacent side. This is the opposite side. It's opposite over adjacent, inverse tan of that, right? So that is second tan of 9.72 times 10 to the minus third, divided by 2.1. This is the way we should be doing it, right? And that ends up being 0.26519 degrees, okay? And then you can use this, right? So n lambda, right? So we're going to go 1 times lambda because we're talking about how far apart one dot is from the next, right? If it was 2 dots away, right? So we're going to go this, we put a 2 there, but it's 1 dot away. Okay, and then that equals the d, which is 0.0895 times 10 to the minus third, times the sine of the angle, which is 0.26519 degrees. Okay, so lambda literally is just going to be this times this, right? Okay, so I'm going to go sine of that number times 0.0895 times 10 to the minus third. And I get 4.14 times 10 to the minus 7th meters. Okay. Now the numbers are just slightly different, but they're not, by the way, they're not different. It's 4, the first one is 4.14257, and this one is 4.142527. So really, this approximation for this guy is working really, really well. We don't have to do all this work. This is more work, right? Okay. But, you know, is it, I don't know if it's better, right? Okay, so what angle separates the central bright spot and the 4th order fringe? What distance is that on the screen? Okay, so 2 ways to do this. Okay. The first way is that, let me just show you. Okay. The first way is that it's just going to be 4 of these things. So 4 times 9.72 millimeters, right, is 4 times, this is basically 4 times 0.972. It's 3.888 centimeters, right? So that's how far, we can do that, right? Because it's the fringes are that far apart, and if we go from the bright spot to the fourth order, we're going 4 fringes away, right? There's a central bright spot, and then this is the first order, second order, third. The fourth order one is 1, 2, 3, 4 of those away, right? So you can just simply do it this way, right? Okay. But obviously, there's a better way to do it. So let's do it this way. Okay, so let's see. N lambda, so 4 times lambda, 4 times 4.1425 times 10 to the minus 7th meters, right, is equal to 0.0895 times 10 to the minus 3rd times the sine of the angle. Right, so the angle is going to be the inverse sine of this divided by this. Okay, so 4 times that guy divided by 0.0895 times 10 to the minus 3rd is that, and then I'm going to take the inverse sine of that. And I get that the angle is 1.06 degrees, right? You can also get the angle as the inverse tan of 0.03888 divided by how far away is the screen, 2.1. This would also better work, right? Because we figured out this triangle thing, right? That we're looking at something that's at a distance of 2.1 meters, something that's 3.88 centimeters, 888 centimeters, right? This is meters. This ought to work too, right? So let's try that. Second tangent of 0.03888 divided by 2.1. Hey, look at that. That's 1.06 degrees as well. Okay, lots of ways to do this. I don't know. There's something in the OCD in me that says, hey, we should use the angles because I know how to do trigonometry now. But anyway, but there's quick ways to do it too, and they work well.